First of all, I would thank all of you, but especially my friends, including and especially Giovanni and Claudio for their kind invitation here to discuss with you about the role of apoptosis in AML. I think that their choice is very good and at least interesting. Why? First of all, we know that in AML, the apoptotic ways are strange, are dysregulated. Indeed, in the extrinsic way, you can see here that inhibitors of caspase 3 and 7, XIAP, are upregulated, while FAD, that have as to increase the activity of caspase 8 and 10, are downregulated. In the intrinsic pathway, we have the increased levels of BCL2, MCL1, and MDM2, while NOXA and TP53 are low. So, in AML, the apoptotic pathways are against apoptosis. I think that the apoptosis is important in our routine clinical life. And we'll see that apoptosis is the target of almost all drugs that we employ in the clinics, but apoptosis is sometimes at least cause of resistance to our drugs, and we'll finish with the future. About the present and drugs that we commonly employ in routine clinics. And we start with anthracycline. We know that anthracyclines are able to induce lipid peroxidation, mitochondrial DNA damage, and so apoptosis through especially the intrinsic way. Cytarabine induces the production of ROS, but also is able to phosphorylate CGN, then increasing levels of that factors, especially of BAX and VAT. So, once again, the intrinsic pathway. And CPX351, you know that we have now this interesting and effective drug that is a liposomal formulation of anthracycline and cytarabine, and we know that the CPX is effective in all patients, especially in those that reach the allogeneic transplantation, but also in the old people and those that we cannot consider eligible for allogenic transplantation. CPX acts by increasing apoptosis, especially by activating caspase 3. But also gentuzumab ozogamicin that now we can use especially in low and intermediate risk patients, acts by inducing apoptosis. Gentuzumab ozogamicin activates BAC and BAX, induces mitochondrial depolarization, activates caspase 3, so inducing apoptosis once again. But we know that the real cure of AML, as Giovanni from many years said, is the synthetic lethality. Not only we have to target neoplasia, blast, but we have also to target microenvironment. And gentuzumab ozogamicin is able to block proliferation and induce apoptosis of stromal CD33 positive cells, so leading a change of microenvironment and so participating to the concept of synthetic lethality. What about FLT3 inhibitors? Also, these drugs act by inducing apoptosis. FLT3 inhibitors act against MCL1, so releasing BIM, and so leading free BAX and BAC, so once again intrinsic apoptotic way. Gilteritinib, in addition to this mechanism, uses the phosphorylation of C-Jean, as we saw for RAC, so increasing once again BAC and BAT. Midostaurin, as first-line treatment, is effective. Gilteritinib prolongs overall survival in FLT3 mutated relapse refractory patient by inducing apoptosis. But I suppose that the drug that we consider as the first one in the scenario of proapoptotic drugs is venetoclax. Venetoclax, by binding BCL2, is able to activate the axis with BIM and BAX, so releasing the cytochrome C and inducing apoptosis. On the other hand, venetoclax is able to decrease the oxidate phosphorylation and to reduce the availability of amino acid for the leukemic stem cell. Venetoclax is more effective when is used in combination, both with daunorubicin and with aracitin. ASA is able to upregulate NOXA, another one part of the apoptotic pathway, and to sensitize cells to venetoclax. So, we have venetoclax in combination with low-dose RAC in the VIALE-C trial and with azacitidine in the VIALE-A trial, when we observed about 50–60% of complete remissions and an increased prolonged overall survival in comparison to low-dose RAC and azacitidine alone. In the last months in Italy, we had the possibility of using for compassionate use even navitoclax. Navitoclax is a good and good inhibitor of BCL-XL, but it is also an inhibitor of MCL1. Navitoclax, we can use this drug in the myelofibrosis and in ALL. BCL-XL, indeed, is overexpressed in MPNs, independently from JAK2 mutations, and navitoclax is synergic with ruxolitinib. Navitoclax plus venetoclax plus chemotherapy in relapse refractory ALL patients is able to offer them 60% of overall response rate and recover about 1/4 of patients to proceed to allogenic transplantation. So, we are convinced that apoptosis is the target for the majority of our drugs. But what about the apoptosis and resistance? We know something from the CLL world, and we know that the resistance to venetoclax is sustained by MCL1 overexpression, CDK9 activation, and BAX mutations. CDK9 is able, by the activation and phosphorylation of RNA polymerase II, is able to activate transcription of several target genes, including MYC and MCL1. You can see here some CDK9 inhibitors. First of all, flavopiridol, alvocidib. Alvocidib before cytarabine and mitoxantrone has been used in relapse refractory AML patients where the resistance was sustained by the increased levels of MCL1. 61% of overall responses with a median overall survival of about 1 year. BAX mutations. BAX is in the apoptosis, is a fundamental point of apoptosis, and you can see here some fish plots. What about BAX mutation? You can see here that in the first three fish plots, you can see that in the resistant patients, we have the appearance of BAX mutations. While in the last one, we observe subclones that became a real clone during resistance and relapse. But apoptosis is not alone. Apoptosis is linked to other pathways, including the epigenetic control. In our lab also, we studied in different diseases the polycom genes, including BMI1 that is overexpressed in AML and EZH2. EZH2 also is overexpressed in this disease and is associated with poor prognosis. When we combine AZH2 inhibitors and venetoclax, you can see here the synergistic effect pro-apoptotic. What about the resistance, apoptosis and resistance to FLT3 inhibitors? You can see that FLT3 mutations are responsible for the early resistance to gilteritinib, but also RAS mutations can be responsible for resistance to FLT3 inhibitors, but we have also the MCL1 overexpression. And when we combine venetoclax with midostaurin or gilteritinib, we have an interesting additional effect. Gilteritinib has been used in vivo with venetoclax for relapse-resistant AML patients. About 70% of efficacy, also in patients who received TKI in the first line with longer overall survival and without early mortality. And for finishing, the future. The future is and includes intrinsic apoptotic pathway inhibitors of extrinsic apoptotic pathway, but also drugs able to restore the TP53 activity. And in vivo, azacitidine has been combined with APR246, the TP53 reactivator, allowing 88% of overall responses, 50% of complete responses, and more than 1 year of overall survival in patients TP53 mutated for was also CPX is not very, very effective. The same chance is not for pevonedistat. The idea is good because pevonedistat is inhibitor of NED8, so it is able to reduce CMYC and to increase NOX. But the Panther study where pevonedistat was combined with azacitidine was not so good because the efficacy of the combination azacitidine and pevonedistat was comparable to azacitidine alone. So, I think that the apoptotic pathways are really deregulated in AML, but I'm convinced that apoptotic pathways are crucial both for drug efficacy and resistance. The majority of our drugs, new and old, have a proapoptotic activity. Perhaps new drugs or combination of incoming drugs could be promising. Sure, we have to increase our knowledge of the apoptosis, and so we need once again to work with biologists. And I would thank you again, my friends, and all of you for your attention.